marks July 12th. It's not the first time that Jamaica was on the air. It's January 31st. It's not the day that Jamaica made a decision to go digital. It's not the day that Jamaica made a decision to use ATSC 3 to go digital. What a celebration of all these things coming together. But as with many celebrations, there is a very serious side to it. We had a wonderful party. We had a great time. We celebrated. But the serious side is now we have to make this real. And we are well on our way, but we have a long way to go. So will July 12th be a special day going forward? Or January 31st, or any of the milestones? Or will we all depart from this event, think about, we had a nice time, we learned a lot, and then we went about our business and didn't really change things very much? Well, I have great faith. Dr. Maria Miles Hamilton and Cordell Green, the Spectrum Management Authority, and Jamaica Broadcasting Commission, Jamaica, gave me a lovely gift. And it said, love, hope, faith. And I have great faith that what we're doing today will have lasting effects. That you will create meetings and relationships that will help you move this platform forward, and that you will make it your own. And that you will contribute back into the ATSC process of developing ATSC 3.0 for not just tomorrow, but for 2030, 2040, who knows. So we are definitely looking forward to that. I will not hold up our program. I would like to get started right away. So I hope everybody was well rested because we have a full day now. Getting back to business. And we'll start with audio and video, and then we will move on to advanced emergency messaging. And then we have some panel sessions afterwards, which in the afternoon, which kind of talk about different use cases that you can use ATSC 3.0. So without further ado, I will invite Alan Stein, Skip Peasy, and Sandy Kosach to the podium. Alan is from InterDigital and shares S41, the group on video, with ATSC. And Skip Peasy is a media consultant representing LG Zenith. And he was the audio system testing manager, so he knows everything that there is to know about our audio system. And Sandy Kosach from Pearl TV is our tag team on the broadcast side, talking about what it has been like to deploy advanced audio and advanced video in the field. Thank you, Alan.
That's unusual. But thank you, and good morning. Just want to give you a brief overview of the things that the audio system in ATSC 3 does, and how it improves upon technologies. There are two main areas that audio in ATSC 3 extends into beyond what we have today or what we're used to with digital or analog television for that matter. And that is, first of all, both a qualitative and a quantitative extension. The first one, in terms of quality, as you know, television audio started with mono, went to stereo, and pretty much stayed there for a while with additions to ATSC television. When we went to digital, we started with stereo and 5.1 surround. That was in the standard, but it took a little while to develop the library of content with that. But cinematic content, all the movies, then became produced in that format, and so it's easy to get at least that whole measure of content. That added 5.1 so-called surround in to the ATSC 1 and other digital TV standards around the world. So 2.0, as we call it, stereo, 2 channels, and 5.1 channels, 5 full frequency channels at once. Subwoofer gave us a plane, a single plane, monitor defines a point, stereo defines a line, 5.1 surround defines a plane. Sound within around the listener, typically, or ideally is seated in the middle of that plane. So what was left, one other dimension was left to go into what was called 3D sound, but not to confuse it with 3D video, which for 3D home video was not a happy kind of thing to try to associate yourself with. So it's called immersive sound. And that's a good representation of it, a good word to describe it, because again, it's with the listener in the center, the entire sphere around, or cube, if you will, around the
somebody will engage on this.
is addressed.
Somebody will engage on this.
Can be addressed by a new system. So the idea was to come up with a system that would allow that kind of immersive presentation. And I didn't tell you, if you've never heard it, the first time you get sound that comes from above, you get height information, it really changes the realism of the sound environment. We forget how much sound comes from overhead. We don't think about up very much. We tend to think straight around us. And all of a sudden, hearing sound coming from above, which it always does out in nature, but we don't really pay attention to. When you hear it in a reproduced environment, it really makes that reproduction sound a lot more realistic. So that's a pretty cool new element of qualitative improvement to the audio system in next-gen TV. And the other element, of course, you said is quantitative change. And that is obviously compression systems have gotten better, so you can put more audio and less bandwidth. But beyond that, the key point that I think is probably most important about the next-gen sound is the so-called personalizable nature. The ability to add personalization to a broadcast sound signal, which could be considered an oxymoron. It's broadcast, doesn't mean everybody gets the same personalization adds the ability to take from a broadcast signal certain elements that you can select to present or not present in your listening environment. So this allows you to do things that we've gotten a little bit used to maybe on DVDs or other online OTT services, but not for broadcast yet. So we can broadcast up to and hopefully beyond what other video presentation systems can do in terms of audio capabilities. And so this allows the user to select the different language for dialogue, to move things around a little bit, perhaps to adjust the announcer to background sound in a game.
Start to focus from the
Either select potentially the home versus the away announcer if the broadcaster provides that to allow different users, different customers, audience members to get different kinds of presentation of the same program and beyond. So there's a whole number of things that there's separate audio description tracks, both for accessibility presentations as well as things like the director commentary that has become popular on DVD. And so on. So there's a whole range of new quantitative changes as well as that spatial qualitative and also just high audio quality with really efficient compression. And so those are the guidelines, the requirements that ATSC put out 7 or 8 years ago when we started this process of developing the audio system. And in audio, we did probably the most significant testing because there weren't a lot of systems out there that did. This was a little forward thinking at the time. And so we put out a call for proposals, and it was a consensus process to get that set of requirements in the call for proposals. And we got a number of responses back. And then we went through those in a consensus process and set up a 2-stage testing program. And we had 3 systems get to the first stage
Easy, brother.
of testing, and out of that first stage, 2 emerged, and those 2 went on to the second set of tests, which took a long time. Again, even the tests themselves were developed by consensus committee, and the components, the test content, the elements that would be used for this subjective listening test in each of those systems. Even that selection process was done by consensus committee. And that was tough too, because we wanted to exercise all the elements we could of the system. So coming up with sound clips that really exercise that immersive sound, 11 channels of at least or object-oriented sounds, so it's always an unlimited number of channels, not really channel-based, but object-based sound, which was also supported in the system. So we had to come up with a way to really hard to get a lot of those elements of content to test, and we finally did, and then went through the testing process, traveled through different countries to do that with the proponents. And ended up finding that both the systems we were testing, one called AC4 from Dolby Labs, and one from the MPEG-H Consortium, Audio Consortium, or Audio Alliance as it was called, which was made up of 3 companies, but currently is now managed by Fraunhofer. So those 2 systems were both tested, and they both really sort of hit all the bars properly. In some cases, one did better than the other, and vice versa. And so the audio group decided, okay, let's accept both of them, and again, leave it to choice of the broadcaster which one to use. Like they did in the transport system with both route and route and MT, and like they've done in other cases where you have a lot of choice and variability. But in this case, we realized there was a bit more of a caveat that had to be added, because even though the encoding of the system isn't done until the very end, the whole nature of the system is not just we felt that ecosystem that would be generated around that should be, could not be interoperable within a given television market or region. So we added the additional requirement that a region should select one or the other. In fact, shall select one or the other. So we're in the 300 standard for that. Meaning that it's ATSC is mandatory to pick one or the other because the systems do not interoperate. Receivers technically should be able to receive either in any part of the world, but in any given part of the world, you should only be using one just to keep the ecosystem simple. And so that's been the way it's worked so far. In South Korea, the MPEG-H system has been this audio system used since their system launch. And in the US, the AC4 system is used. And in Brazil, where they're still deciding what they want to do, they have already decided about audio. And they'll be using the MPEG-H system there as well. So different countries, different systems. Again, ATSC3 provides a choice, and that's where we're at now. So I'll stop there and move over to Alan to do video. But I'm willing to talk to any of you if you have deeper questions about audio specifically. Thanks.
Good morning. My name is Alan Stein. I am the chair of the ATSC S41 video group, and I have a short presentation to sort of give you a overview of the video capabilities of ATSC 3.0. So the current ATSC video system is based on HEVC. HEVC is an MPEG cover. It's high efficiency video. So ATSC did was add constraints and optional features around HEVC. and that's what's fielded today. And I'll talk a little bit about some of those advanced options that we're hearing about. Ultra HD, 4K, HDR, high frame rate, all that good stuff. And then I'll also talk a little bit about a new codec called VBC. VBC is the latest from MPEG. It's a versatile video codec and it's the successor to ATSC. And ATSC is in progress of specifying VBC as a second video codec to exploit the benefits of that. So this is now this video on the slide. So the basic capabilities of ATSC video can go up to 4K. So 38, 40 by 2160, or 2160p, that's 4K video. We support spatial scalability with an extension of ATSC that is called SSC. And that has some interesting uses. We support high frame rate. So you may not have seen this. Videos now not just shot in 50 or 60 frames per second. It actually can be shot in up to 120 frames per second. It looks great at high frame rate. And it turns out that the additional bit rate needed to support high frame rate is actually relatively small compared with going to 4K. 4K costs you about 3 times the number of bits. High frame rate maybe costs you 15-20%. So there's a lot of bang for the buck with high frame rate. We also have techniques to allow decoders that can't do high frame rate to actually decode at 660. So they don't have to decode at 120. So it's like totally not done. And then high dynamic range. I'll get into this in one. There's a number of flavors, there's a number of ranges for HDR. You probably heard Dolby Vision, HDR 10 plus, or advanced HDR by Technicolor. So I'll also explain ATSC supports all of these, and I'll talk a little bit about that.